Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today we are going to see how to solve a traveling salesman problem using branch and bound algorithm. We have seen in the previous videos how to solve traveling salesman problem through Hungarian method, and now today we are going to take the same question that we have taken in the previous lecture and we will solve this question using branch and bound algorithm. So let us quickly see what the problem is. The problem says that a salesman wants to visit cities A, B, C, D and E. He does not want to visit any city twice before completing his tour of all the cities and wishes to return to the point of starting journey. Cost of going from one city to another in rupees is shown below. Find the least cost route. So this is the cost matrix it is given, and in place of 0 from city A to A, B to B, we have put a dash sign just to make sure that there is a restriction on the salesman going from one city to the same city. So we have just put a dash sign here, and now the first step we used to do in branch and bound algorithm is to find the lower bound value. So first is to calculate the lower bound value. Now what is a lower bound value here? So lower bound value is nothing but the sum of minimum value in each row. So we can see this in each row there is one minimum value. Suppose for row 1 minimum is 1, for row 2 it is 2, for row 3 it is 4, for row 4 it is 5, and for row 5 it is 1. So adding up all these values will give us our lower bound value. So let us quickly calculate the lower bound here. So for row 1 the minimum value is 1, for row 2 the minimum value is 2 plus 2, for row 3 minimum value is 4, so plus 4, for row 4 minimum value is 4, again plus 4, for row 5 minimum value is 1. So our lower bound will come as 12. Okay, so 12 is our lower bound value. And what this lower bound shows? Our lower bound shows that the salesman, when completing the tour, will have at least 12 rupees as its expenses. That means the total expense of touring for the salesman is either 12 or more than 12, and it cannot go below 12. So this is the value of lower bound, and in this particular matrix we can see that this is an asymmetrical matrix where the cost is dependent on direction. That means if it is going from A to B the cost is rupees 2, and if it is returning from B to A the cost is rupees 6. So it is depending on certain criteria. So this is an asymmetrical matrix, and for asymmetrical matrix we have different values if we calculate the lower bound for row and if we calculate the lower bound value for column. And if there is a symmetrical matrix we will have the same value of lower bound whether we calculate for row or we calculate for column. We can approach anyway. We can also go using row wise or using column wise. So in this problem I am going to calculate the value of lower bound from the value of in each row. Okay, so let us start again. Now as we have seen that the lower bound value is 12, so this is the minimum value, Now what we will do is we will try to assign in different cells and see what are the possible changes in the lower bound value. Suppose let us assign this particular cell, because A is not possible, it has been restricted. So let us assign this particular cell A, B. So once this cell has been assigned, that means salesman will go from city A to B. So he will go from city A to B. So once he goes from A to B, it is certain that he could not return from B to A. This cannot happen now, as it has been moving from A to B, because if it is returning from B to A, it will form a subtour which violates the traveling salesman rule. So once this cell has been allocated, we can see that no more assignment can be done in this column and in this row. So now we can see that our matrix will now be reduced to, okay, let me write here, our matrix will now be reduced to B, C, D and E. Since there is no more assignment can be done here, similarly no more assignment can be done in B, so this has been reduced to A, C, D and E, and the values here will be 6 dash 3 8 2, similarly 8 7 dash 4 7, similarly for D it is 12 6 dash 5, for E it is 1 2 8 and dash. So we can see this. Now after assigning this, our matrix has been reduced to 4 cross 4 matrix with B, C, D and E, A, C, D and E. Now again we will calculate the lower bound for this particular position. So we can see that for row 1 here minimum value is 2, here minimum value is 4, here minimum value is 5, here minimum value is 1. So adding up all these, we will have 2 plus 4 6, 6 plus 5 11 plus 1 12. So this lower bound for this 4 cross 4 matrix is coming as 12, and we have also assigned this particular cell, that means this will be plus 2. So 12 plus 2 will be 14. So we can see that if we assign x a b equal to 1, this is cell AB. So if x a b equal to 1, our lower bound will changes from 12 to 14. Okay, and similarly what we will see is we will try to assign in AC, AD and AE. So let us do x AC equal to 1, x AD equal to 1, okay, and x AE equal to 1. So let us see one by one what are the changes in our lower bound values will occur. So let us see here, and one more thing we need to see in this matrix, as we have been saying that if the salesman is going from A to B, then he cannot go from B to A, and here in this matrix we have a cost value from B to A. So what we will do is we will just remove this value, and instead of this value we will put a dash sign here, okay, so that this will be restricted. That means once he is going from A to B, he could not return from B to A. Now let us move further. Let us see if we assign AC. Okay, so let us see if we assign A, C. So if we assign this particular cell, we can see that no more assignment can be done in A and C, and our values will change accordingly. So this will be B, A, B, D, E, and B, C, D, E. Okay, and the values here will be 2, A, B to B is dash, B to B is dash. Okay, this will be 6, this will be dash, this will be 7, 4, 3. So now, as we are saying here that now the salesman is going from A to C, A to C. So once he is going from A to C, it is certain that he could not return from C to A. This could not be happening. So in this matrix also we can see that there is a cost coefficient from C to A. So we will erase this, and instead of this we will put a dash sign here. So I am just putting a dash sign here. Now again we will calculate the lower bound for this particular 4 cross 4 matrix. So we can see that this will be 2 plus 4 plus 4, that is 10 plus 1, 11. 11 is the lower bound for this 4 cross 4 matrix, plus it has a value of 5. So 11 plus 5 is 16. So we can see that when we are assigning cell AC, we are getting our lower bound value as 16. Now let us assign the value AD. So let us assign this. So I am not drawing the matrix each time, we can understand from this particular matrix only. Now as we can assign this particular value, we can see that no more assignment can be done in A and D, and our matrix reduced to B, C, D, E, and A, B, C, and E. So among these the lower bound condition will be, and before that we make sure that if salesman is going from A to D, he could not return from D to A. This is not happening. So let us again calculate the value here from A to D. The minimum value here is 2, and this is not 2 plus 7, 9, 9 plus 4, 9 plus 4 is 13, 13 plus 1, 14, 14 plus this 7 is 21. So this lower bound is coming as 21. Similarly, if we assign cell AE, that means if it is going from A to E, if it is going from A to E, we can say that it could not return from E to A. This is not happening. Okay, so here again we will see that this AE cell has been assigned, and once this is assigned, no assignment can be done in A row and E column. So our matrix has been reduced to this 4 cross 4 matrix where E to A is not possible, so we will not consider this 1. Now let us take the lower bound value. 3 plus 4, 7 plus 4, 11, and now this one cannot participate, because if this participate, the salesman will return from E to A, which will violate the condition. So instead of that we will prefer the second least value, that is 2. So this will be 3 plus 4, 7 plus 11 plus 2, 13. 13 plus 1, 14. So here for AE, the value of lower bound is coming as 14. So we have done till here. Now we will see that which of the lower bound values is the smallest, and we will start solving ahead. As we can see that when we are assigning cell AB, we are getting the value 14, and when we are assigning the cell AE, we are getting the value 14, and these two are minimum values. So we will start solving these two separately. So let us see here. So once this has been assigned, okay, so once the cell AB equal to 1 has been assigned, and among the remaining 4 values, let me show the diagram or the matrix again, so it will be more clear. Now if we have drawn this, we have this 4 cross 4 matrix, and among these matrix, now once it is going from A to B, then we will see from B it can go to how many cities, and we will try to assign each one of them one by one. So as for this matrix, B can go to A, but which is not feasible with this, because here it is going from A to B. We have selected this cell, that means it cannot go from B to A. So we have a restriction here, we cannot assign here and we cannot assign here. So we can do either BC, that means after this it may go to BC, that means X BC equal to 1. This is one condition. Similarly, it may go to BD. So X BD equal to 1, then it will have a certain lower bound condition. And similarly BE, if it will go to X BE equal to 1, then it will have a certain lower bound condition, and we need to calculate this value. And in order to calculate this, first we will take XBC, that means we will assign this particular cell, and once this cell has been assigned, no more assignment can be done in this particular row and this particular column. Now our matrix again has been reduced to 3 cross 3 matrix, where we have C, D and E, and here we have A, D and E. So let us see C and A, and it is going from A to B to C. So CA will be 8, CD will be 4, CE will be 7. Similarly DA will be 12, DD will be dash, DE will be 5, EA will be 1, ED will be 2 and EE will be dash. So as we can see here that it is going from A to B and B to C. Now it cannot return from C to A or C to B, because it will form a subtour which is not essential or which will violate the traveling salesman problem. So C to A and C to B is not possible in this particular case. So we can say that we have one value as C to A, and now what we will do is we will remove this value, and instead of this value we will put a dash sign here. So now again we will calculate the lower bound for this 3 cross 3 matrix, which is 4 plus 5 9 plus 1 10. So here the value is coming as 10 plus 3 plus 2 5. 10 plus 5 is 15. So the lower bound for this condition is coming as 15. Now let us assign the other cell. We have seen by assigning BC. Now let us see what will be the lower bound if we assign BD. D. So if we assign BD, again our lower bound value changes. So this will be A, this will be A, C and E, and this is C, C will be dash, this will be 8, this will be dash, C, D, C will be 6, E, C will be 2. Now we need to see that in this particular situation it is going from A to B and B to D. A to B and B to D it is going. That means D cannot go to B or D cannot go to A. These two are not happening in this case. So as we can see here, DA is given, so we will remove this value, and instead of this value we will put a restriction here by having a dash sign. So now again we will calculate the lower bound for this case, which is 7 plus 5 12, 12 plus 1 13, and 13 plus 8 plus 2 10. 13 plus 10 is 23. So now for this condition our lower bound comes to 23. Now let us change this and let us try to assign the value BE. So let us assign this value BE, and the matrix here changes the form A, C and D. This will be A, C and D. Okay, and the values here will be D to A will be 12, this will be 12, C to D is 4, D to D is dash, E to D is 8. So now we can see that the salesman is going from A to B and B to E here, A to B and B to E. That means it cannot go from E to A or E to B. These two conditions are not going to happening in this case. So we can see here that EA has been given a value, so we need to erase this, and instead of this we will put a dash sign here. So we will put a dash sign here, and now again we will calculate the lower bound for this particular 3 cross 3 matrix. So for this the lower bound will be 4 plus 6 10 plus 2 12, 12 plus 2 plus 2 4, 12 plus 4 is 16. So for this the lower bound is coming as 16. So now we have calculated all the possibilities here, and again we will select the minimum value and try to solve further. So as we can see here, if we are assigning XAE equal to 1, we are having the minimum lower bound value as 14. So we will try to solve further, and for that we will first assign this value AE we will first assign this value AE. So this has been assigned, and now after assigning this our matrix has been reduced to this 4 cross 4 matrix. So once the salesman is going from A to E, we need to see that from E it will move in which direction. So we will see this particular row, if it goes E to A, E to B, E to C, E to D. Okay, so let us see the possibilities. We can see here that it may go from X, A to E, E to A. Because it is going from A to E, it cannot go from E to A. So first E to A is not possible, so we will not calculate this. next it may go from E to B. So X E B equal to 1. It will have some value. Similarly, it can go from E to C, then X E C equal to 1. It will have some lower bound value. Similarly, it can go from E to D. So X E D equal to 1 and it will have some lower bound value. Now we will calculate one by one what will be the lower bound value for these conditions. So let us see first when the cell XEB is assigned. So XEB, that means if this cell is assigned, now no more assignment can be done in row A and row E. Similarly, no more assignment can be done in column B and column E. So our matrix will now be reduced. Now our matrix will be reduced from B, C and D to A, A, C and D, A, C and D. Now let us write the values here. B to A is 6, B to C is 3, B to D is 8, C to A is 8, C to C is dash, C to D is 4, D to A is 12, D to C is 6, D to D is dash. And now after we have seen how our matrix has been reduced, again we will see the series in which the salesman travels. So it is going from A to E and now from E to B. So this means that it cannot go from B to E or B to A because it will create a subtour. So B to E and B to A is not possible. So we can see that we have a situation with B to A. So we will erase this value B to A and instead of this we will put a dash sign here to make restriction. So again we will calculate the lower bound, which is 3 plus 4, 7, 7 plus 6, 13. Now 13 plus 3 plus 1, 4. 13 plus 4 is 17. So for XEB equal to 1, the value of lower bound is coming as 17. Similarly, now we will try to assign cell EC. So if we assign cell EC, our matrix or reduced matrix will change from E, A, B and D. So we can see that we will again see the values, and for B to A it is 6, for B to B it is dash, from C to B it is 7, from D to B it is 4. And we need to see that the salesman is moving from E to C this time. So E to C, that means it cannot move from C to E or C to A. So these two conditions are not possible here. So we can see that we have a C to A value here. So we will erase this value and we will put a restriction here by just writing a sign here, okay, a dash sign. Now we will calculate the lower bound for these values. So this is 6 plus 4, 10 plus 4, 14. 14 plus 2 plus 1, 3. 14 plus 3 is 17. So the lower bound for this is also coming as 17. And now we will see what will happen if we assign the value E D. So if we assign this particular cell E D, then what will happen? Our matrix will be reduced to B, C, D and A, B and C. So the value C to A is 8. Similarly, B to C is 3. C to C is dash. D to C is 6. And again we need to see the sequence in which it is going. So the salesman is going from A to E and E to D. So it is moving from E to D. This means it cannot go from D to E or D to A. So these two are not possible, and we can see that here we have a value for D, A. So again we will erase this value and we will put a dash sign here, and we will calculate the lower bound for this matrix. 3 plus 7, 10 plus 4, 14. 14 plus 9. 14 plus 9 is 23. So this lower bound value is coming as 23. So now we have calculated all the values here, and again we will select the minimum lower bound value. Now the minimum lower bound value is existing when we have the value BC equals to 1. That means it is going from A to B, B to C. So let us see if it is going from A to B and B to C. Let us solve this further. So first we will assign A to B. This is 2, A to B, and B to C, 3. Now among the remaining matrix, okay, remaining 3 cross 3 matrix, we will see that from B to C it is been moving. Now from C to which other place it can move. So let me write here. It is moving from A to B, B to C. Now it cannot move from C to B and C to A because it will create a subtour. Okay, so it cannot move from C to B or C to A. So these two are not possible. So we can see that it cannot go from C to A, it cannot go from C to B, it cannot go from C to C. It can either go from C to D or C to E. Okay, so let us see. X, C to D, C D equal to 1, and X C to E, C E equal to 1. So now we will see that if we assign C D, that means if we assign this particular cell, then our matrix has now been reduced to 2 cross 2 matrix, 12, 5, 1 and dash, and from this it cannot go from C to B, C to A. Okay, so we can see that the lower bound is 5 plus 1, 6. Okay, 6 plus 4, 10, 10 plus 5, 15. So here the value coming of lower bound is 15. Similarly, if we do not assign this particular cell and instead of this we will assign the cell CE, CE. If we assign this cell, again our matrix has been reduced to 2 cross 2 matrix. This 12, dash 8 and 1. 12 dash 8 and 1. So 12 dash 8 and 1, the minimum value here will be, this is D to A, A to B, B to C, C to E. Okay, this is 12 plus 1, 13, 13 plus 5, 13 plus 7, 20 plus 5, 25. So it will coming as 25. So now we can see that we have a series where salesman is going from A to B, B to C, C to D for this particular case. So now the only way it can go is from D to E, because it cannot go from D to C, D to B or D to A, as it will create a subtour. So after this it is very clear that it will move from D to E and from E to A, because after reaching E it has completed visiting all the cities. So this is the series, and this is optimal because this is showing the value here as lower bound value as 15, and no other values will be equal to or less than this. So we will eliminate all the other values. So this has been eliminated, 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 and these three has been eliminated. So after seeing this, let us calculate the value from of z minimum will be given as A to B is 2 plus B to C is 3 plus C to D is 4 plus D to E is 5 plus E to A is 1, and this will be equal to, this is 5 plus 5, 10, 15. This is 15 rupees. So now I hope this is clear how we can solve the traveling salesman problem by branch and bound technique. There are different versions of branch and bound, and what we have done here is one of the most basic version, which is very easy to understand. And I hope if you have any doubt regarding this method, please watch the video again, so you will have a clear idea of how to use a branch and bound algorithm to solve the traveling salesman problem. So if you like the lecture, please share the lecture. Have a nice day. Thank you.